Morning. Today in this live lecture we shall discuss the genesis of a first order partial differential equation. That is the origin of starting of a first order partial differential equation. Actually, in this section there is an expectation to express the basic idea, basic concepts regarding the genesis of regarding the first order partial differential equation. So already we have studied the first order partial differential equation and their types. We shall again write some terminology regarding the first order partial differential equation in the section of genesis of a first order partial differential equation. Actually, the base of the partial differential equation is from the curves, starting from the curves. See, this ordinary differential equation, we can express the given curve in the terms of ordinary derivative. But if the curve is in three-dimensional geometry, then it is the locus of intersection of two surfaces. Curve means it is the locus of intersection of two curved surfaces. Suppose this is the first surface, this is another second surface. If two surfaces are intersect each other, then the common points belonging to the both these surfaces is called as a curve in three-dimensional geometry. We can express the equation of a curve. This is the actually curve. We can express the equation of a curve in terms of, this is a curve, in terms of parametric form is x is equals to f1 of t, y is equals to f2 of t, z is equals to f3 of t. This is the parametric equation of the curve in the three-dimensional geometry. But in the geometric form, you must know the basic idea regarding the curve in three-dimensional geometry. Curve in three-dimensional geometry, it is the intersection of two surfaces. Yesterday we have seen that काल जो लास्टला पार्ट पाहिलेला आहे कर्वच्या बाबतीमध्ये, कर्व इन थ्री-डायमेन्शनल जॉमेट्री, डेरिवेटिव्ह, पार्शियल डेरिवेटिव्ह रिगार्डिंग द कर्व. सो हा जो लास्ट बीट आहे पीडी रिगार्डिंग कर्व, in 3D, which can be expressed in terms of a PDE. हे काल जो लास्टला पार्ट मी घेतला होता त्याची हेडिंग अशी टाका, मिक्स प्रॉब्लेम मध्ये मिक्स करू नका. कर्व इन 3D or PDE. See this, you know that there is a relation between curve and ordinary derivative. If curve is y is equals to x square plus 4x plus 1, if curve is y is equals to x square plus 4x plus 1, this is a curve in two-dimensional geometry. It has a dependent variable 1, independent variable 1. If we differentiate this, then we get the ordinary derivative dy by dx is equals to 2x plus 4. That means we will get the tangent derivative. Derivative means which gives a slope of a tangent. Means there is a relation between curve in two dimension and ordinary derivative. Similarly, there is a relation between curve in three-dimensional geometry and PDE. This can be expressed here. हा जो पार्ट आहे, लास्ट बीट आहे पहा, याला आपण असं म्हणू. हो काय हे दिस इज द लास्ट पार्ट. मी परत एकदा रिवाइज करतो, विद्यार्थ्यांना ते लास्ट पार्ट परत एकदा समजावून सांगायचे. तुम्हाला माहित आहे पहा, कर्व इन 2 डायमेन्शनल जॉमेट्री अँड देर इज अ रिलेशन बिटवीन ऑर्डिनरी डिफरन्शियल इक्वेशन. तुम्हाला माहित आहे, by using the ordinary differential equation we can obtain the slope of a tangent to the curve. We can find the nature of the curve. We can find maxima minima of the curve. Means the lot of applications we can obtain from the ordinary derivative which are corresponding to the curve. तुम्हाला माहित है, यहाँ पे देखो कर्व और ऑर्डिनरी डेरिवेटिव के बीच में बहुत सारा रिलेशन होता है. Curve, if curve is in 2-dimensional geometry, then we can observe the nature of a curve in different views in the different directions by using ordinary derivative. In the same process, if a curve is in 3-dimensional geometry, then we can observe the nature of a curve. We can find maxima minima of the curve in the 3-dimensional geometry by using a partial derivative. That means you must know there is a close relation between curve in 3-dimensional geometry and partial derivative. So how to discuss this? आता हे कसं डिस्कस केलं जातं त्याची ही हेडिंग टाका, कर्व इन 3-dimensional geometry, ब्रॅकेटमध्ये टाका PD. त्याचं रिलेशन कसं आहे PD. सपोज वी नो दॅट, त्याची ही डायग्राम पण काढा. सपोज दिस इज अ कर्व. सिंपल दुसरी पण डायग्राम काढला तरी चालतं, एखादी अशी डायग्राम काढा. वी कॅन ड्रॉ दिस डायग्राम. Suppose this is x-axis, this is x-axis, this is y-axis, and this is a z-axis. Then curve in 3-dimensional geometry. This is the curve in 3-dimensional geometry. So its equation in the parametric equation of the curve is, याचं equation असतं x is equals to f1 of t, y is equals to f2 of t, and z is equals to f2 of t. Suppose, so इथं लिहायची गरज नाही आहे. So the point on the curve, any curve is, suppose that point is consider x comma y comma z. That means हा पॉइंट असतो, हा पॉइंट. That means this distance on x axis is x, distance on y axis is y, and vertical distance on a z axis, this gives us a small z. So we can express any point in the curve which is in the 3-dimensional geometry. Curve in the 3-dimensional geometry. We can obtain the position of a point in the 3-dimensional geometry. And this position of a point we can write in the form of parametric equation. So let us go back to the equation of the curve. X is equals to f1 of t, y is equals to f2 of t, z is equals to f3 of t. This is the equation of the curve in the parametric form. In the parametric form. So now we can eliminate t from f1 and f2. आता f1 is a function of t, f2 is a function of t, so we can eliminate f1 t from function first and function second. And if we are going to eliminate t from f1 and f2, then we will get another function phi which is in terms of x and y. So we obtain the relation, म्हणजे पहा उदाहरणार्थ, for example here, suppose x is equals to t, y is equals to t square. These are the function, and suppose z is equals to again 2t. Then we can remove this. We can solve 1 and 2. X is equals to f1 of t, y is equals to f2 of t. If we solve this, फर्स्ट आणि सेकंड जेव्हा सॉल्व करतो तेव्हा आपल्याला असं रिलेशन मिळतं. याला सॉल्व केल्यानंतर y is equals to x square, means x square minus y is equals to 0. So मग ही स्टेटमेंट काय सांगते पहा, सेम इलिमिनेटिंग टी बिटवीन F1 and F2 we obtain the relation phi of x comma y is equals to 0 काय आहे. एक्झाम्पल सांगितलं मी, phi of x comma y is equals to 0. Similarly, see this, similarly we can F1 and F3 मध्ये, आता F1 आणि F3 मध्ये जर तुम्ही इलिमिनेट केलात, F1 आणि F3 मध्ये जर इलिमिनेट केला तर कसं येतं पहा, हा F1 आणि F3 मध्ये जर इलिमिनेट केला तर कसं येतं, z is equals to 2x. So 2x minus z is equals to 0. So we get another function of x comma z which is denoted by psi of x comma z. So this we get the psi of x comma z which is the another function that means psi of x comma z. हे सांगितलेलं आहे, हे समजलं नव्हतं विद्यार्थ्यांना, विद्यार्थ्यांनी थोडं रिपीट करा म्हटल्यामुळे मी हे करतोय. मी काय सांगतोय तुम्हाला, ज्याप्रमाणे ऑर्डिनरी डेरिव्हेटिव्ह आणि कर्वचं रिलेशन असतं, ऑर्डिनरी डेरिव्हेटिव्ह म्हणजे 2 डायमेन्शनल कर्व आणि ऑर्डिनरी डेरिव्हेटिव्ह, तसं 3 डायमेन्शनल कर्व अँड पार्शियल डेरिव्हेटिव्हचं रिलेशन असतं, ते कसं असतं हे या ठिकाणी सांगतोय. सो वी गेट, इफ वी इलिमिनेट t from x f1 and f3, then we get another function psi which is in the form of x and z which is equals to 0. Hence curve can be thought as the point of intersection of two curves. म्हणजे आता तुम्हाला माहित असेल, पॉइंट ऑफ इंटरसेक्शन ऑफ टू कर्व्स, टू सरफेसेस, सॉरी 3 डायमेन्शनल जॉमेट्री मध्ये कर्व म्हणजे पॉइंट ऑफ इंटरसेक्शन ऑफ टू सरफेसेस. इथं दाखवलेली आहे डायग्राम, टू सरफेसेस. Its parameter s in the equation of the curve is the length of the curve measured from some fixed point. Then it is given by dx by ds, dy by ds, dz by ds. This is the parameter which is in terms of a length. We can measure from fixed point, which is measured from fixed point. And yesterday we have seen one example, equation of a line. Equation of a line in 3 dimensional geometry having a fixed point x0, y0, z0. So we can express x is equals to x0 plus ls, y is equals to y0 plus ms, and z is equals to z0 plus ns, where l, m, n are the direction cosines of a line. Same process here, dx by ds, dy by ds, dz by dx are the direction cosines of the tangent to the curve at a point s. Tangent to the curve at a point s. म्हणजे हा tangent s ला कुठल्या त्या पॉइंटला जर tangent असेल तर, suppose that the curve C having the coordinates s of x, x of s, y of s, z of s lie on the surface s whose equation is f of x comma y comma z is equals to 0. This is the equation of the surface. And if this point also lie on the curve, आता तुम्हाला माहित आहे, if a point lie on the curve, curve is the intersection of the both these surfaces, so that point is also lie on the surface. This is the equation of surface. Then we can write the equation of a surface by using s, where s is the parameter. So we can write f of x of s, y of s of x, z of s of x is equals to 0. आता याचं जर तुम्ही डिफरन्शिएटिंग केलात विथ रिस्पेक्ट टू s, तर f is a function of x, x is a function of s. So we have to differentiate it partially. मग ते तुम्हाला कसं डिफरन्शिएट करावं लागेल, पार्शियली डिफरन्शिएट करावं लागेल. मग पार्शियली डिफरन्शिएट करत असताना डो f by डो x, because see this, it is the function, capital F is a function of x, x is a function of s. So dou f by dou x into dx by ds. आता इथं d का घेतलं तर x is a function of only s. लक्षात घ्या, इथं d का घेतलं, here डो न घेता d का घेतलं, because x is a function of s. s is only one independent variable. So we have to take this as a partial derivative. Similarly this, which is equals to 0. This is the condition that the tangent to the curve at C at the point px comma y comma z, which is a perpendicular to the line having the direction ratio dou f by dou x plus dou f by dou y plus dou f by dou z. Okay, it may be noted that the curve C is arbitrary except for the fact that it passes through the point P and lies on the surface. Therefore, we can conclude that the line whose direction ratios are given by dou f by dou x plus dou f by dou y plus dou f by dou x comma dou f by dou y dou f by dou z, that is LMN. Suppose direction ratios are given by, we can consider A, B, C, suppose, is a perpendicular to the tangent for every curve lying on S and passing through the point P. Therefore, they give the direction ratios of a normal to the surfaces at the point P. म्हणजे thus these are the basic idea or the relation. अशा पद्धतीनं we can relate the concept of a partial derivative and the curve in 3-dimensional geometry. हे काय दाखवतं, ही थिअरी काय सांगते पहा, तुमच्याकडे नोट असू द्या. ज्याप्रमाणे कर्व इन 2-dimensional geometry आणि ऑर्डिनरी डेरिव्हेटिव्ह याचं रिलेशन असतं, दॅट मीन्स वी कॅन ऑल्सो ऑब्झर्व द नेचर, म्हणजे आपण नेचर ऑब्झर्व करू शकतो. आणि हे नेचर ऑब्झर्व करत असताना सपोज दिस इज अ पॉइंट पी अँड द टँजंट ॲट द पॉइंट पी. आता इथं आपण टँजंट काढू, त्याचे आपल्याला डायरेक्शन रेशोज वगैरे घेता येतील. सो वी कॅन राईट दिस टँजंट हिअर. टँजंट ॲट अ पॉइंट पी आणि मग त्याचे डायरेक्शन रेशोज dou f by dou x, dou f by dou y, dou f by dou z, which is on the surface, both these surfaces. So this is the relation between curve in 3-dimensional geometry and partial derivative. म्हणजे हे आपण रिलेशन दाखवलं थेरॉटिकल फॉर्म मध्ये. ओके, नाउ वी शॅल मूव टुवर्ड्स द जेनेसिस ऑफ अ first order partial differential equation or the basic idea regarding the first order partial differential equation or origin of the partial differential equation. हे ऑलरेडी आपण पाहिलेलं आहे, तरी मी थोडक्यात लिहून देतो, तुम्हाला माहीत पाहिजे म्हणून आपल्या थेरॉटिकल भाषेमध्ये लिहून देतो, तुम्ही समजून घ्या. हा सांगा रे, मुलं ॲब्सेंट राहायला लागले, ठीक आहे. पार्शियल डिफरन्शियल इक्वेशनची डेफिनेशन सांगा. हाऊ टू चला सर्वांनी पार्शियल डिफरन्शियल इक्वेशनची डेफिनेशन लिहा, मी फक्त नोटेशन सांगतो. By a partial differential equation, which is actually denoted, shortly denoted by PD. त्याला शॉर्टली कसं दाखवलं जातं, कसं म्हटलं जातं, PD. Partial differential equation which is a PDE. We mean an equation of the form फंक्शनच्या फॉर्म मध्ये लिहू, f of x, y, z, t dot 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 whatever may be, u, ux, uy, dot 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 again uxx, uxy, in this way dot dot dot, which is equals to 0. Means which contains term of x, dependent variable, independent variable, its derivative, it may be second order derivative. Then equation of this type, suppose this is considered as 1. So the equation of this type is called as a partial derivative. So involving, see this involving two or more independent variables x comma y comma t etc, whatever may be. One dependent variable that is u of x comma y comma t dot dot dot, which belongs to c raised to n in some domain D, and its partial derivative and its partial derivatives ux, uy, dot dot dot, uz, whatever may be, dot dot dot, uxx, dot dot dot. Okay, where c raised to n, c means the set of a complex number, c raised to n denotes the set of functions, denotes the set of functions possessing continuous partial derivative of order n. Of order n. Okay, this is actually the definition of a partial derivative in the detail. An equation of the form f of x comma y comma z t dot 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 u ux uy dot 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 u double x uxx uxy uyy whatever may be dot 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 is equals to 0, involving महत्वाचं म्हणजे काय, involving two or more independent variables x y u whatever may be, x y t etc dot 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 etc. One dependent variable u which is belongs to c raised to n in some domain D, and the partial derivative ux uy u double x etc, where c raised to n, cn means denotes the set of functions possessing continuous partial derivative of order n. See this, a PD is thus relation between, आता याला शॉर्ट मध्ये कसं लिहिता येतं, so a PDE is a relation between the dependent variable u, dependent variable u and some partial derivatives at every point x comma y comma t dot 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 in D. This is the scientific definition of the partial differential equation. ओके, आता फर्स्ट ऑर्डर हे फक्त पार्शियल डिफरन्शियल इक्वेशनची आहे, फर्स्ट ऑर्डरची नाही आहे. दिस इज द डेफिनेशन ऑफ अ पार्शियल डिफरन्शियल इक्वेशन. ओके, ठीक आहे. हां ठीक आहे. आता ही जी आपण तुम्ही जी डेफिनेशन सांगितलेली आहे वन डिपेंडंट व्हेरिएबल, दिस इज द रफ आयडिया ऑफ द डेफिनेशन ऑफ द पार्शियल डिफरन्शियल इक्वेशन. ओके. तुम्ही परत बऱ्याचशा चुका करतात. पुन्हा आता दुसरी कन्सेप्ट आपण इथं घेऊ. नोट, the order of a partial differential equation, the order of partial differential equation to be the order of the derivative of highest order order of the derivative of highest order है. n occurring in the equation. सेकंड. बाकीच्या ज्या बेसिक कन्सेप्ट आहेत त्या ऑलरेडी आपण डिटेलमध्ये अगोदर घेतल्या. ऑर्डर म्हणजे काय, कशी फाइंड आउट करायचं, हे पण डिटेलमध्ये घेतलेलं आहे. पुन्हा टाइप्स ऑफ पार्शियल डिफरन्शियल इक्वेशन इन द फर्स्ट ऑर्डर हे पण घेतलेलं आहे. त्यामध्ये नोट टाका, अ पीडी इज सेड टू बी quasi-linear if the derivatives of highest order which occur in the equation are linear. थर्ड नोट, ही तिसरी नोट सुद्धा लक्षात ठेवा. अ क्वासी-लिनियर पीडी is said to be semi-linear. We have already seen linear, semi-linear, non-linear, quasi-linear. That is the types of a first order linear differential equation. Okay, we have studied this. त्यातला नोट सांगतो मी. Semi-linear if the coefficient of highest order derivative, if the coefficient of highest order derivative do not contain either the dependent variable or its derivative. See this. These are the genesis of a partial differential equation of first order. Genesis of a partial differential equation of the first order. Basic concept, basic idea or origin. A semi-linear partial differential equation a semi-linear partial differential equation short is said to be linear partial differential equation if it is linear in the dependent, if it is linear, if it is linear in the dependent variable and its derivative. याची डेफिनेशन पण ऑलरेडी आपण घेतलेली आहे. And the last, a PDE which is not a Quasi-Linear, a PDE which is not a Quasi-Linear PDE is said to be non-linear. See this. Now we can write the differential equation. Generally, 6. The general form of partial differential equation in first order is f of x comma y comma z comma p comma q which is equals to 0, where p is equals to zx means dou z by dou x, q is equals to zy which is denoted by dou z by dou y. Generally, actually we know that we are using maximum 3-dimensional geometry along x-axis, y-axis, z-axis. Generally z is considered as a dependent variable, x and y are considered as an independent variable. So the general form of a first order partial differential equation we can express in the form of f of x comma y comma z comma p comma q, where p is equals to zx, z suffix x, q is equals to z suffix y. Okay, and this is the famous, or in the maximum number of books we can use. Already we have used this partial differential equation of the form f of x comma y comma z comma p comma q. This is okay. So this is the basic concept regarding the partial differential equation. या ज्या concept आहेत या व्यवस्थित लक्षात ठेवा. याला म्हणतात basic concept regarding partial differential equation, origin regarding the partial differential equation. Now next we shall discuss example based on surface of revolution. Example, see the surface of revolution. Suppose that this is a x-axis, this is y-axis, and this is z-axis. Now surface of a revolution, if any curve is revolving around the z-axis, then we get a surface. See this, I shall explain this concept. एक माहित राहो, surface of revolution means what? Suppose this is x-axis, this is a z-axis and a y-axis. Suppose this curve is revolving, we write this. Suppose this curve is revolving along z-axis, about the z-axis, then what will happen? So it will be gives the surface, अशा पद्धतीनं surface मिळेल. This is the surface due to the revolution of a curve about z-axis. About z-axis. See this. समजतं का पहा? And so here we consider a point, suppose px comma y comma z. So this distance is called as x. The distance on y-axis is called y. And this length is suppose r. Small r. So we can write r square is equals to x square plus y square according to the Pythagoras rule, or law of a parallelogram. We can find r is equals to x square plus y square. This is the point. This is the point. Suppose this point, whatever may be, we can express this r in terms of x square y square. And हा जो point आहे z, this is the function of r. We consider this is a function of r. So this is a function of r. So here z is a function of r, px comma y comma z. So we can express this curve, revolution of a curve about z-axis in the form of, see this. So I shall write the theory. Many surfaces of revolutions here, many surfaces of revolution with z-axis, r axis as the revolution, see this, many surfaces of a revolution with z-axis as axis of revolution are of the form, how we can write? Z is equals to f of r, comma, we have given r is equals to root of x square plus y square. Pythagoras rule नुसार we can write x square plus y square bracket raised to 1/2. हे Pythagoras rule नुसार r काढा, diagonal of the base of a right angle triangle, which is denoted by, and this r, this is the function of r, we can express in the form of z. So z is equals to function of r, त्याला आपण capital F घेऊ, function of r, where r is equals to root of x square plus y square. That means we can express number of the function, many surfaces which are revolving about z-axis. Actually surface is generated. We can generate the surface by taking the revolution of a curve about z-axis. So it can be represented generally in this form. या फॉर्म मध्ये लिहू शकतो, where f is a arbitrary continuous differential function, where capital F is an arbitrary continuous differentiable function. आता now by differentiating, now z is equals to f of r, differentiating partially with respect into x and y, then we get, आता x आणि y ना जर तुम्ही डिफरन्शिएट केला तर काय होतं, then we get p is equals to dou z by dou x which is equals to, आता r चा डेरिव्हेटिव्ह घेतला dou z by dou x which is equals to dou f by dou r into dou r bar by dou s, dou x, dou r bar, dou r by dou x. So we can write this as p is equals to dou f by dou r into, आता याचा डेरिव्हेटिव्ह घ्या, dou r bar dou r अपॉन dou x चा डेरिव्हेटिव्ह घ्या. काय येतो याचा डेरिव्हेटिव्ह, पॉवर मल्टिपल मध्ये पॉवर 1 न कमी पहायचा डेरिव्हेटिव्ह घ्या. dou r bar by dou r upon dou x is equals to 1 by 2 inner bracket x square plus y square bracket raised to minus 1 by 2 into 2x into काय येतो 2x, मी घेतो वाटलं तर. सो 1 by 2 into x square plus y square bracket raised to minus 1 by 2 into पुन्हा derivative of x square is 2x. So 2x will be get cancel आणि हा 1 upon x लिहिला. So p means dou z by dou x is, which is equals to dou f by dou r into x divided by x square plus y square bracket raised to 1 by 2. So it is given by p is equals to x divided by, यालाच आपण r लिहितो, x square plus y square bracket raised to 1 by 2 यानी कि r, x divided by r into dou f by dou r. So it is also denoted by fp is equals to x divided by r into f dash of r. Suppose this is equation number 1. This is equation number 2. If we differentiate partially with respect to x, similarly differentiating 1 partially with respect to y. हाँ चला बरं सांगा काय येतो. सेम आता प्रोसेस ना, इथं आपण दोन्ही न लिहिता एकच लिहू. हाँ काय येईल सांगा रे स्टुडंट. p means actually dou z by dou x which is denoted by p. dou z by dou x means dou z by dou f by dou r into dou r bar by dou x. So we have to calculate in this way. आता परत f dash of r. मग आता सिमिलरली याचा कसं लिहिता येईल पहा. सेम प्रोसेस मध्ये वी कॅन राईट q is equals to dou z by dou y which is equals to dou f by dou r into dou r bar by dou y. So it is denoted by dou f by dou r into y divided by x square plus y square bracket raised to 1 by 2. Means same we get the relation q is equals to y by r into f dash of r. Suppose this is equation number 3. This is the equation number 3. Now we have to eliminate f dash of r from 2 and 3. We have to eliminate f dash of r from 2 and 3. बरोबर आहे ना स्टुडंट्स. हाँ ओके मी डायरेक्ट लिहिलं इथं. नाउ eliminate the function f dash of r फ्रॉम 2 and 3 कसं इलिमिनेट करता येईल पहा. इथं पहा एफ डॅश ऑफ आर ची व्हॅल्यू काय, पी आर अपॉन एक्स. एफ डॅश ऑफ आर ची व्हॅल्यू पी आर अपॉन एक्स. सो वी कॅन राईट हिअर पी आर अपॉन एक्स विच इज इक्वल्स टू, from equation 3 we can write f dash of r means qr upon y. So also rr, we can remove this rr also. So we can write p divided by x which is equals to q divided by y. So this can be written as py is equals to qx. So it is called as a py minus qx is equals to 0. किंवा यालाच आपण असं लिहू शकतो, that means y into dou z by dou x minus x into dou z by dou y which is equals to 0. This is the partial differential equation. See this. This is the first order partial differential equation satisfied by the surface which is revolving about a z-axis. This is very important. This is the first order partial differential equation. This is the first order partial differential equation for the surface which is revolving about z-axis. So we can write here, this is a general, a partial differential equation of a first order satisfied by the revolution of the form above. हे समजला का रे प्रॉब्लेम सर्वांना? हा पार्शियल डिफरन्शियल इक्वेशनचा फॉर्म कसा आला असं सुद्धा विचारू शकतात. प्रॉब्लेम क्वेश्चन कसा विचारतात, फाइंड द पार्शियल डिफरन्शियल इक्वेशन फॉर द सरफेस which is revolving about the z-axis given by the equation z is equals to f of r, comma r is equals to x square plus y square bracket raised to 1 by 2. अशा पद्धतीनं क्वेश्चन येतो. r म्हणजे आता ते कसं आलं काय नाही हे तुम्ही समजून घ्या. This is the partial differential equation. This is the first order partial differential equation for the surface which is generated by revolving the curve around the z-axis. म्हणजे इथं या ठिकाणी here our interest is to show the relation between the partial differential equation and the surface, because it is the basic idea. It is the basic idea of the partial differential equation. माझा इथं इंटरेस्ट काय तर तुम्हाला रिलेशन समजून सांगायचं आहे. पार्शियल डिफरन्शियल इक्वेशनचं आणि सरफेसचं क्लोज रिलेशन असतं हे तुम्हाला समजून सांगायचं. जसं वन डायमेन्शनलमध्ये कर्वचं आणि ऑर्डिनरी डिफरन्शियलचं रिलेशन असतं, कारण वी कॅन write the nature of the curve depend on ordinary differential equation in the two-dimensional geometry. In this way, same, we can define the nature of the curve or surface in the three-dimensional geometry by using the partial differential equation. मग हा प्रॉब्लेम मी एक एक्झाम्पल आहे, प्रॉब्लेम आहे. क्वेश्चन आहे, विचारतात, खूप महत्वाचा क्वेश्चन आहे. फाइंड द फर्स्ट ऑर्डर पार्शियल डिफरन्शियल इक्वेशन फॉर द surface of a revolution given by the curve z is equals to f of r, comma r is equals to x square plus y square bracket raised to 1 by 2. So this is the complete solution for this. समजला ना हा प्रॉब्लेम, तुम्हाला व्यवस्थित समजला का? ओके. सो नाउ वी कॅन राईट, वी कॅन इलिमिनेट, वी कॅन कन्सिडर द अनदर एक्झाम्पल रिगार्डिंग द जॅकोबियन. तर ठीक आहे, ते आपण एक्झाम्पल उद्याला घेऊ. सेकंड एक्झाम्पल आहेत, त्या पद्धतीचे एक्झाम्पल्स आहेत, वेगवेगळे एक्झाम्पल्स आहेत, प्रॉब्लेम्स आहेत. वी शॅल डिस्कस दिस इन द टुमॉरोज लेक्चर. वी शॅल स्टॉप हिअर. ओके.